Good morning, students. Is my voice clear? Good morning, students. My voice clear? If you have any query, write in the chat box. Okay, I am looking in the chat box also. I am going to start the class now. Okay, now I am going to start the class. In the last class, we discussed about the mechanical properties of solids. Now I am going to start the next chapter, that is the mechanical properties of fluids. This is the very important chapter. Okay. Students, write in the chat box. Is it clear? Okay. Anshu, Nandini, right? Kavita, you gave the response. Thank you to all. Okay. And ask your friends to join in the class. A very important chapter we are going to start. And that is mechanical properties of solid fluids. Mechanical properties of fluids. This is my chapter name. Okay. Mechanical properties of fluids. What is a fluid? Right? Can anyone tell what is a fluid? Fluid means what? Fluid means what? Okay. Fluid means the substance which flows, right? The substance which can flow is called as the fluid. Fluid is the substance that can flow, right? What are the examples of the fluid? Liquids and gases, collectively called as fluids. Okay, liquids and gases collectively called as the fluids, because that can be flow from one place to another place. And next, I'm going to explain one topic based on the mechanical properties. If you apply the force on the fluids, what changes will occurs, and what are the properties of the fluids, that we are going to discuss in this chapter. And next one is the density. What is the formula for the density and what is the definition? Density means, can anyone write in the chat box what is the density? What is density? Density is the mass per unit volume. Mass per unit volume. Mass per unit volume is called as density. Then how to write the formula for the density? Density formula is density of any substance. Formula is mass by volume. Mass of substance by volume of substance, if you will do, you will get the density. This is the formula for the density. Density can be denoted with sometimes rho or sometimes d also. Okay, and the rho formula, density rho is equal to that is mass by volume, m by v, we write. Its unit, what is the unit of the density? SI unit of density is, mass unit is kg, volume unit is meter cube. Volume means length into breadth into height. That means it we write as meter cube. Okay, mass by volume. Mass by volume. That means that is kg per meter cube we write. This is the density. Okay, and if you want to write dimensional formula for this, okay, dimensional formula for the density. Dimensional formula is mass is the fundamental physical quantity. Volume depends upon length, breadth, height. Length into breadth into height. Everything is length only. L into L into L into then we will get L cube, then we will get as m L power minus 3. This is the dimension formula of density. Okay, CGS unit also we have the gram per centimeter cube. Gram per centimeter cube. 1 kg per 1 gram per centimeter cube is equal to, you will get as 1000 kg per meter cube. Okay, 1 gram per centimeter cube is equal to 1000 kg per meter cube. How you will convert this one? Gram is 10 to the power of minus 3, centimeter is 10 to the power of minus 2, 10 to the power of minus 2 meter, 1 gram equal to 10 to the power of minus 3 kg, 1 centimeter equal to 10 to the power of minus 2 meter, 10 to the power of minus 2 whole cube means 10 to the power of minus 6 meter cube, 10 to the power of minus 3 kg, 10 power minus 6 goes to numerator, we will get that 10 power minus 3 plus 6, we will get that 10 to the power of 3 kg per meter cube, right? In order to convert gram per centimeter cube into kg per meter cube, we have to multiply with 1000, right? Okay. And the next, let us go for the next concept. If you want to take, you take the screenshot. And the next concept is that density on what factors it depends. Density depends upon nature of material. Density depends upon nature of material. It is independent of, it is independent of mass and volume. Actually, density formula is mass by volume, but the density does not depends upon mass and volume. Okay, for example, if you take the copper, okay, if you will increase the mass, then the volume also increases, mass proportional to volume, right? That's why it is independent of mass and volume. It depends upon the only nature. Different substances having the different densities. Okay, right. And next one is the some density of mixtures we are going to find out. For example, different substances, I mixed the water with kerosene or some other substance with some other, then the density of mixture, how we can find out? Okay, if we mix the two or three liquids, okay, at the moment that combined liquid density, how we can find out? Then for that, let us consider first, there are two cases are there. Consider two liquids of densities rho 1 and rho 2. It is not P, it is rho, and volumes V1 and V2 are combined. Then what is the formula to find out the density of mixture? Then density of mixture, I want the density of mixture. Then for the density of mixture, we have the formula rho mix density of mixture equal to, we have the total mass by total volume. This is the formula. Okay. First liquid mass is m1, second liquid mass is m2, m1 plus m2 by v1 v2. This is the formula. But m1 we don't know here. In our data, they gave the first liquid density rho 1 and first liquid volume v1. First liquid mass we can find out, that is the rho 1 v1. Second liquid mass we can find out rho 2 v2. Then we have the formula, that is rho 1 v1 by plus rho 1 rho 2 v2. Density of mixture formula for this is rho 1 v1 plus rho 2 v2 by v1 plus v2. This is the formula for the density of mixture when two different liquids having the densities rho 1 and rho 2 and having different volumes v1 and v2 are combined to form a single liquid, then the density of the liquid formula is this one. Okay, if volumes are equal, if v1 is equal to v2 is equal to v, then we write the density of mixture we will get as, I think you will get very easily, density of mixture we will get as v1 is v, v2 is v, we will get as rho 1 plus rho 2 by 2. Is it right? Okay. Now Let us go for the second case, that is in this densities they give and volumes they give. In the next case that they are giving the density of mixture, we can find like this, that consider two liquids of masses m1 and m2, comma, densities rho 1 and rho 2 are combined, then density of mixture, density of mixture, that formula is rho mix is equal to total mass by total volume m1 plus m2 by total volume is v1 plus v2, we have to write. In our data, masses they gave, that is m1 plus m2, and total volume we have to write. v1 v2 did not give in the data, then we can find out the v1. We have the formula, that is rho 1 is equal to m1 by v1, right? We know this. We can write like this: rho 1 is equal to m1 by v1, and rho 2 is equal to, we write as m2 by v2. From that v1 v2 formulas we have to write, that is what you will get v1 v2. Can you tell? We write it as v1 is equal to m1 by rho 1, m1 by rho 1 plus m2 by rho 2. Then we will get as m1 plus m2 by m1 rho 2 plus m2 rho 1. If we will do the row LCM, then we will get into rho 1 rho 2 also. This is the final formula that we are getting for the density of mixture. That is density of mixture formula we will get is m1 plus m2 into, so I think here it is not possible, it will not appear, right? This is only formula, and this is about density of mixture. You take the screenshot and note it. Next I am going to erase this everything, and then you take the screenshot. Next topic I am going to start. Till now, is it clear, students, what we discussed? What is fluid? And till now, we discussed about something, that is what is a fluid, and what is the formula for the density, and what factors it depends, and density of mixture, how we can find out these things we discussed. And the next topic is relative density. What is relative density? What is relative density? Till now, is it clear, students? Any doubt? Any query? Anish, Vishal, any doubt? Okay. Let us go for the continuation. That is, the next topic is the relative density. Relative density or specific gravity. What is this? What is relative density? Relative density means that is related to some others, right? Relative density of a substance we can find out like this. It is the ratio between density of a ratio between density of a substance to the density of water. Density of water is called as relative density. Relative density of substance. If you want to find out the relative density of any substance, just it was very simple that relative density of substance is equal. Just you have to divide the density of substance with the density of water. Okay, density of water. At 4 degrees Celsius, the water has the maximum density that we have tried. This is the relative density. The relative density not have any unit. SI unit is okay, actually no unit because density by density and no dimension formula also. No unit and no dimensional formula. This is about relative density. Now let us go for the next topic. Next topic is the pressure. What is pressure? Okay, we will study this pressure concept. Pressure is the normal force per unit area. Normal force per unit area is called as pressure. Okay, pressure formula is force by area, that we write as P is equal to F by A. This is the formula for the pressure. Okay, pressure unit I want to write. SI unit of pressure. What is the unit of the pressure? Pressure unit is force by area, that is Newton per meter square, or we write as Pascal. Okay, Pascal is a unit of the pressure. There are several units are there for the pressure. Okay, this is the one unit. Next one is the I'm going to explain one concept. Okay, that is here you see this is a one sharp nail we will take. Okay, top nail. It is pressed on your skin, and one more blunt nail. Okay, reversely we are pressing. Another one also nail like this. It is there. We are pressing this one. Both of them we are pressing to the wall, to the skin. Then which will affect the 1 and 2 out of these two, which will affect more on skin? We are applying the same force effect here. For example, here I am applying the F force. Here also I am applying the F force. Here cross section is very less, A1 cross section. Here cross section is more, right? This is A2. Here in the figures, A1 is less than A2, right? Area of cross section of this first one is very much less than comparing with the second one. Which will injure more for the skin? This is the skin. On the skin we are pressing both of them. Then which will injure more, and whose effect is more on your skin? Right, the first one, because its cross section is less. Even though we are applying the same force, the effect of the first one is more. First nail is more than the second nail because the first nail has a sharp edge. The sharp edge means its cross section is less. When the cross section is less, the pressure is more. It can passes, it can pierces through your skin if you will apply the more force, but it cannot pierce and it cannot damage your skin much, but it can damage. That means the effect of force is more in case 1 comparing with the case 2, right? This is the pressure. Okay, pressure is the effect of force. Effect of force is more in the case 1, right? That is the pressure. And now pressure not only depends upon the force, it depends upon the area also. Okay, right. And now I'm going to explain one concept. We are going to study the liquid pressure now. That is the Pascal law. I am going to explain Pascal law. Right, till now is it clear, students? Any doubt, write in the chat box. And if you joined lately, then write your roll numbers. Okay, the attendance is very important. I am your class teacher, right? I am noting the attendance every day. You must present in the class. Now let us start. The next concept is the Pascal law. Pascal law and its proof. State and prove the Pascal law. It is important for the 3 marks. What is Pascal law? The Pascal law is that the pressure of the liquid is the same at all points which are at the same height. Pressure of liquid is same at all points. Pressure of liquid is same at all points which are at the same height. Which are at the same height. Okay, right. What is this? Very simple. If height is constant, okay, if the liquid height is constant, then the liquid pressure is also constant. This is our Pascal law. Okay, it's a proof I am going to explain. Okay, the proof of Pascal law. Then I have to show that pressure of the liquid is the same at all points if that points are at the same height. Okay, it was very easy proof. You listen it here. It is depends upon the trigonometry formulas. Can anyone write the formula for the sine theta cos theta? Let us take the some liquid at here. This is a container. You see here. This is a container. This container has some liquid. This is the liquid. Okay. I am keeping. I am taking some triangular column at here. Okay. I am taking the triangular column of the liquid. Liquid column I am taking, that is in triangle shape. This is the liquid column. It is in the triangle shape. This angle is theta. This triangle is A, B, C we will take. Okay. This is a triangular column. Okay. Its height is very negligible. Okay. Our triangular liquid column we are taking. Triangular liquid column with negligible height. With negligible height. With negligible height. Very carefully how to hear. And here we have some areas at here. The area of this one, okay, I will take it as capital A, small b. This is opposite to B point, okay, B corner. Force on this side, liquid exerts the force in all directions. The force on this side we will take as F suffix B. And this side, the force we can take as F suffix C. This is opposite to C point, okay. And the area of this one we can take as A suffix C. And the force on this side is we can take as F suffix A. And area of this one we will take as A suffix A. This angle is theta, okay. This angle is theta now. Now let us go for this one. From the figure we write, we have to show that the pressure will be same on three sides because it is very uh, less height triangular column we are taking. Okay, for that purpose we have to take from figure. We can write one thing, that is sine theta we write as opposite side by adjacent side. What is the opposite side pressure? Okay, sine theta opposite side is FC force if you want, right? On the opposite side the force is FC. Theta opposite side force is FC. By hypotenuse we have taken, not adjacent side. I said adjacent side but it is wrong. Tan theta means opposite by adjacent side. You will get angle opposite side is force is FC. Hypotenuse force is FB. FC by FB we have to write. This formula we can also write in areas also. Opposite area is A suffix E and hypotenuse area is, okay, this is a triangle, rectangle, triangle. This is angle opposite is opposite side. Angle adjacent side is the base is the adjacent side. This is the hypotenuse. AB is the opposite side. BC is the base, okay, adjacent side, and AC is the hypotenuse. AC by A suffix C by area of this opposite side by hypotenuse area you have to take. Hypotenuse area is A suffix B. I am taking, okay, right. And from above equations we can do one thing, that this is from above equations we write like this. Sin theta we equated like this, na, FC by FB sin theta equal to AC by AB. We write FC by FB is equal to, we write as AC by AB also. We take AC to left side, okay, right. Force on C side by area of C side, okay, but is equal to force FB by AB we write. Okay, this is equation 1. And the next we can continue now. Okay, previously we took the sine theta. Now I am going to take the cos theta, right? Okay, you take the screenshot. Okay, I am going to continue now. Right. And from figure we write cos theta also. How to write the cos theta? Cos theta we write as adjacent side by hypotenuse. We write as FA by cos theta is the adjacent side. Adjacent side is the BC by AC we write. On BC side force is FA. How I took this as FA, this as FB and this as FC? I am taking the triangle ABC na. B opposite face force on this is the point B. Opposite to this B is this face. On this face force is F suffix B. Area is AB. C is, this is the corner, this corner, and C opposite face is this one, and on this force is FC, and C opposite side, opposite face, okay, area is AC, and A opposite one is area is this one, okay, A suffix A, force is F suffix A. Understood? Cos theta what we write, adjacent side by hypotenuse we write FA by FB we have to write. And cos theta we can also write like this in the terms of areas. Adjacent area we have to write AA, by hypotenuse area we have to write as AB. And from these two equations, okay, from these two equations we write like this. FA by FB is equal to, we write as AA by AB we write. From this if you write like this, we take this AA to left side, FB to right side. FA by AA is equal, we will get as FB by AB we will get. This is equation 2. And from equation 1 and 2 we write something like this. From equation 1 and 2, from equation 1 and equation 2 we do like this. That is FA by AA is equal to FB by AB is equal to, we write as, okay, FA by AA is equal to FB by AB, but FB by AB equal to FC by AC, right? Then we write like this. This is the pressure. Force by area is the pressure on A side equal to pressure on B side equal to pressure on C side. That means this triangular column has the three sides. On the three sides, the pressure is the same. If you consider that the height of the triangular column is same, that means if height is almost constant, we are taking in the figure, it is very small and negligible, okay, and then the pressure will be constant. Pressure is also constant. Understood? This is the proof of Pascal law. Take the screenshot and note it. If you have any query, write in the chat box. Students, is it clear now till now? Any query if you have, you write in the chat box. Now I am going to continue. I am going to erase these all things. Now we discussed about the Pascal law and its proof. Next one I am going to explain that very important topic, very important topic. That is the variation of pressure. Variation of pressure with the depth of liquid. We go to the depth of liquid, deep and deep in the liquid, then how the pressure of the liquid changes. Pressure means what? Normal force per unit area. That pressure, how it will varies with the depth, that we are going to study now. For the purpose, we can take one, this is container, okay, this is a container, this is a long container, it is in the cylinder shape, okay, and this container is having the liquid now, okay, and this is the liquid. And this is the liquid. Now we are taking the some liquid column that is in the cylinder shape. This is a liquid column. क्लास बंद करके आना है बोल रहे क्या? ठीक है बोलिए आ रहे 10 मिनट में. We are considering one cylindrical column, okay, that cylindrical column height is h, okay, and the cylindrical column cross sectional area we will take as a, and the pressure of the liquid at here we can consider as the P1. The pressure of the liquid at this depth we can consider as P2, okay, and now what we are doing it here, we are going to verify, where we are going to study the variation of pressure with pressure of the liquid with the depth, how pressure of the liquid changes with increase in depth, that I am going to explain. If you have any doubt, you write in the chat box, okay. For this we are taking one cylinder, okay, that is filled with the liquid, and we are taking the a cylindrical column. Consider a cylindrical liquid column of height h and area of cross section capital A. Now consider a cylindrical liquid column of height h and area of cross section A. Now what are the various force acting on the liquid column? On the upper side the force will act in the downward, that force is F1. On the lower side of the force will act, that is F2. Okay, the weight of this liquid column acts downward direction, that is mg. Okay, right. But this liquid cylinder, this is also liquid only, this liquid is at rest, right? And now we have to write the forces formula. Downward force on cylinder, downward force, what are the force acting on the for cylinder? Downward force on upper face of cylinder, right? And the upper face downward force will acting. That downward force formula is, right, if it is its area is a and the pressure is at here is p1, then we write as force is equal to pressure into area, right now. And upward force, this is acting in downward direction. Upward force on lower face of cylinder, right, that is p2a, this is upward direction. And weight of liquid column in which direction it is acting? Weight of liquid column is mg, that is acting in downward direction. But the liquid column, cylindrical liquid column is in equilibrium, is it right? Under these three forces, cylindrical liquid column, actually side forces also acts, but they will cancel with each other because they are at the same level. Liquid column is at rest. Liquid column is at rest means upward force equal to downward force. Is it right? What are the upward force acting it here? That upward force are the F2 plus mg. Is it right? F2 is upward. Sorry. Upward force is only F2. Downward force is 2 are there. That is F1 is there and mg is there. F2 formula what we write? P2a. F1 formula what we write? P1a is plus mg. The next continuation we have to write. How to simplify it? Then we have to take m is the mass of liquid column. Okay, mg is the weight of the liquid column, na? Right. That's why m is the mass of the liquid column. Mass of the liquid column we write like this: P2a is equal to P1a plus mass of the liquid column we write as density into volume. Density into volume. Volume we write as area into height. Then area is common and cancel. What you will get? P2 is equal, we will get as P1 plus rho GH we will get. This is the formula to find out the pressure condition we are getting from this equation. Okay, right. Next, let us continue. From the diagram, we got this formula. I will explain clearly. You don't worry. I'm going to continue now. Now, if upper face of cylinder, is at a free surface of liquid, then what happens? For example, I'm taking, this is a cylinder, okay. Oh, sorry, it is a cylinder vessel, and it contains the liquid now. Okay, I am taking the cylindrical liquid column, but the free surface of the liquid column is at the free surface of the liquid column is upper face of the cylindrical liquid column. This one, this small cylinder liquid column is at the free surface of the liquid. Right here the force is F1, but here the pressure we can take as PA. Here we will take as the pressure PA, atmosphere pressure. Okay, and at here the pressure is PA, and at a depth H the pressure at here we will take as P. Okay, here this is the P1 and this is the P2. P2 is we can take as P, and then we can write the condition if the free surface, if upper face of cylinder, okay, at free surface of liquid, then we write the on the upper face pressure, upward pressure on the upper face pressure is P1, that is equal to atmosphere pressure, atmospheric pressure, atmospheric pressure. What is the pressure on the lower face? P2 is the pressure on lower face. Pressure on lower face. That P2 we will take as the P. Okay, that is the P is the pressure at a depth H. We write as P is equal from above equation. This is equation 1. And we write from equation 1, we write like this. From equation 1, we write as P is equal to PA plus rho GH. Okay, this is the formula. P is what at here? P we write as pressure at a depth H. Pressure at a depth H in liquid. What you got it here? From this we can write one thing, that just P2 is the P. What is the P2 actually? In above equation you see, just you see this diagram, P2 is the pressure at the lower face of the cylinder, and this is the upper face of the cylinder, right? At here pressure is P1. This we are taking at here, means at here atmosphere pressure will be there. Let P1 become PA, and P2 is the pressure at a depth H we will get. That is the pressure at a depth H is we are taking as P. Then pressure at a depth H formula is PA plus rho GH. P, that means at H depth, here I want the pressure. Above this one liquid column is there, that liquid pressure, plus above this air is there, air pressure. That means we write as the pressure at a depth H in the liquid is equal to atmosphere pressure plus liquid pressure. This rho GH is the liquid pressure. Okay, and rho GH is the liquid pressure. Okay, then finally we can give one conclusion, that what happens to the pressure. Pressure of liquid when height depth increases, right? H is the depth. H is the depth of liquid. Is it right? From the surface. Okay, if you will increase the H, then the P also increases. Pressure of liquid increases with increase in depth. This is the formula to find out the pressure at certain depth in the liquid. Okay, and for example, if anybody asks to you find, this is a pond or the swimming pool. Okay, one person is swimming at certain depth in the liquid. At H depth, one person is swimming, and here atmosphere pressure is there, and here above him liquid is there. That liquid pressure also there. What is the pressure on this fellow? Okay, pressure on this fellow is what? Pressure on this fellow is atmosphere pressure plus liquid pressure, that we can find out the pressure of swimmer. Okay, who is swimming at depth in the liquid? Formula is P is equal to, okay, pressure on swimmer. Who is swimming? Okay, swimming at who is swimming at a depth H in the liquid? Who is swimming at a depth H? The formula is PA plus rho gh, right? What is rho at here? Where rho is the density of liquid, density of liquid, is it right? It means the pressure at certain depth in the liquid depends upon the density of the liquid and height of the liquid, acceleration due to gravity, atmosphere pressure. Okay, right. Remaining we will continue in the next class. Thank you to all. I am going to close, and if you not give the attendance till now, you write in that chat box. Okay, and then closing the class. Thank you to all.